my name's Manan, and this is Dan, and today we'll be going over how to design an experiment.
The only way to determine if there's a cause and effect relationship between two variables is to conduct an observational study.
Don't you mean an experiment?
No, I mean an observational study.
You fool, that's wrong. You just lost points. The only way to determine if there's a cause and effect relationship between two variables is to conduct an experiment. Be careful not to infer causation from observational studies, which use correlation.
Oh right, I forgot. Even if there's a strong correlation between two variables, it doesn't always mean that one causes the other. There may be underlying factors called confounding and lurking variables that have not been controlled for. Because this is an experiment and we want to determine causation, there needs to be a treatment imposed, and subjects will be assigned different levels of the explanatory variable.
The experiment we'll be designing today is to test how caffeine affects test performance. The population that we want to gather information about is the students at Newton South. Suppose that we've already gathered a simple random sample of subjects. If our subjects were not people, they would be called experimental units.
First, we need to identify the explanatory and response variables. The explanatory or independent variable is the amount of caffeine. In our experiment, there will be different levels of the explanatory variable. Subjects will receive pills with 0, 50, and 100 milligrams of caffeine. 100 milligrams is the amount of caffeine in 1 cup of coffee. The response or dependent variable would be the performance on the exam following the treatment. We will measure performance based on the number of questions answered correctly. There are 3 basic principles of experimental design. 1.
Control.
2.
Randomization.
3.
Replication.
The first principle of experimental design is controlling the effects of lurking variables on the response. We compare the control group with the experimental group to determine whether the treatment has effect not due to chance or confounding variables. In many cases, what causes the effect is not the treatment itself, but rather the subject's expectations and the belief that medication often results in improvement. This is known as the placebo effect. In our experiment, the control group will receive 0 milligrams of caffeine. To control for the placebo effect, the control group will get a sugar pill that looks exactly like the caffeine pills.
This way, the control group will not know how much caffeine they're actually getting. We will also control for the placebo effect in other groups by not telling any of the subjects which treatment they are receiving. This is known as a single-blind study. This controls for subject expectancy bias, where a subject's knowledge of the treatment influences their performance.
But sometimes the experimenter can inadvertently influence the results because of their knowledge of the treatment. To eliminate the observed expectancy bias, we will run a double-blind study, where neither the experimenter nor the subjects will know who is receiving which treatment. A third party should hold the information which identifies the subjects and which treatment they received.
The second principle of experimental design is randomization.
We use randomization to assign the subjects to the treatments. We can only compare the effects of several treatments if they are all applied to similar groups of experimental units. Otherwise, systematic differences between the groups of experimental units in a comparative experiment can cause bias, which we want to avoid. We also want to make sure that we use an impersonal chance to assign the experimental units to treatments, and not rely on the judgment of the experimenter.
One way we can randomly assign subjects to treatments is to put all the names into a hat, and the first third pulled out will be assigned to the 100 milligram pill. The second third pulled out will be assigned to the 50 milligram pill, and the remaining will receive the sugar pill. The third principle of experimental design is replication.
Replication is a repetition of an experiment or observation in the same or similar circumstances. In our experiment, we need enough subjects to reduce chance variation. As sample size increases, variation decreases.
Finally, after we obtain our results, we need to test whether or not they are statistically significant, meaning the observed effect is so large that it cannot be the product of chance.
Before we can generalize our results, we have to realize that there could be a lack of realism. The subject, or treatment, or setting in the experiment may not realistically duplicate the conditions we really want to study. Thankfully, in our study, the lack of realism isn't a problem.
You don't think it suffers from a lack of realism?
No.
You fool! That's wrong! You just lost points! Most people do not normally get caffeine from pills. This environmental difference might have changed their bodily response.
Psychology and statistics have an intertwined relationship. Meaningful research in psychology cannot exist without the use of statistics and experimental design. The modern use of statistical methods in psychology can be dated back to 1860, when psychologist Gustav Fechner began applying statistics in his research in psychophysics. He is credited with introducing quantitative methods into psychology and developing a theory of collectives built on the frequency interpretation of probability. By the time Hermann Ebbinghaus published his work of experimental study of memory in 1885, it had become clear that the experimental approach to psychological research was here to stay. Today we will be interviewing our psychology teacher, Ms. Jessica Engel, about the use of experimental design and statistics in psychology. So, hello.
Hello. Thanks for having me.
Yeah. So this year we were able to conduct some psychology experiments in our senior class, and I have a few questions. So what would you say are some of the difficulties of conducting social psychology experiments in high school setting?
Yep. So what I ask students to do is find an experiment and replicate it, or if they want to change it in some way, they can design it on their own. And what can be difficult about doing that is that we're in a very limited setting, right? So if they're using students of the school, which generally use to conduct the experiment, your only data is representing Newton South High School, or it might just be representing Newton South seniors. Some students go outside of school, but they're still, not using a process of random assignment or random selection in getting their population. So I would say that's the trickiest part of conducting it.
What would you say you saw in our projects, the use of statistics and experimental design, the basic principles that were covered?
Yeah, so what I see most commonly is that students find correlations, and often find very strong correlations, and really come to understand the difference between correlation and causation. So I can talk about it and I can show you guys studies, but until you are realizing what your confounding variables are and what you can't control in the experiment, you really come to understand why you're just able to prove that there are relationships between things, but not that one necessarily causes the other.
Okay, so what would you say some of the confounding variables that you noticed in your students' experiments were?
So there are a lot of things that my students either couldn't control or didn't realize they should control in their experiments. And a good example was two students who conducted a study on just salutations and saying hi to people when they were entering, I think, 3 different locations, the library, the front of the school, and then they also went to one location outside the school. And they would greet the people coming toward them and then assess the greeting, like whether they acknowledged them or not and what they said, and then graph that by gender. And they were trying to draw the conclusion that responses were made based on what gender the person was, which was okay. They had some data to show a relationship between whether someone was a girl or a boy and how they were greeted. That said, some of the confounding variables were who these people were, how they perceived the 2 greeters, the fact that the greeters were also the people who designed the experiment, right? So they may have also been, greeting the females in a certain way different than the males and causing them to respond a certain way. So it wasn't necessarily just gender, but their own bias. It could be the personality of the people they were greeting, not their gender. Could be their mood that day. Could be where they were heading, if they were in a rush or not. So,
things that they
yes.
could control
Yeah, and what I do is I know that there are a million things that my students can't control for, so as long as they're addressing what the confounding variables are in the experiment, or at least naming a lot of them, that's okay.
Right, because one of the confounding variables that I found in my experiment studying the correlation between color and gender was that we were trying to study whether boys would tend to go towards a blue sheet of paper,
Right.
and then on a different desk we put a pink sheet of paper, and we were trying to see if there was a strong correlation with girls in pink. And unfortunately, one of the confounding variables was that people tended to sit near the direction that they were walking from, so we couldn't control, like, where they were walking from.
Yeah.
And so we found that there wasn't a strong correlation between gender and color, but it was probably because the direction they were walking from.
Yeah, absolutely. It's fine. It's one of the things that people most want to study are the gender differences, but it's one of the hardest things in which to find
Right.
causation.
There's so many confounding
Yeah.
variables. Now you've all learned how to design an experiment.
Thanks for watching our video.